Hello, friends. This is a quick how-to video on how to handle Chapter 5, an exam on blackjack and probability. Okay. I am going to go through every question on this one just because then it's easier, I think, to take the actual test. So, yeah, and it'll be quick, promise. Okay, so first thing is So we're going to find the theoretical probability of this. A 12-sided die is rolled. A set of equally, so these are the different possibilities when you roll a 12-sided die. We want to find the probability of getting a number greater than 7. So the way you do probability, on the bottom is the amount of outcomes. And there are 12 different sides to this dice, so there are 12 outcomes. And let's find how many are greater than 7. 1, 2, 3, 4, 5 of them are greater than 7. So that means the probability of this, and we can't reduce that fraction at all, is going to be 5/12. And we're right! Yay! Next one. Okay. Same deal. This one, we have, again, a 12-sided dice. So the denominator will be 12, but they want to know the probability of rolling a number greater than 20. And unfortunately, that can't happen here because there's only 12 sides. So this would be a probability of 0 out of 12 or just 0. That's what we would put. So when it can't happen, it's a 0. Okay, you are dealt one card from a standard 52 card deck. Find the probability of being dealt an ace. So in a 52 card deck, there's obviously 52 cards, and there are 4 different suits, and each suit has an ace. So 4 out of 52 of those cards are going to be aces because there are 4 different aces in every deck. And if you're ever not sure, you can always just Google how many aces are in a deck and it would tell you. So we reduce 4 out of 52 because they're both even, and you end up with 1 out of 13. That's what this fraction would be. Don't forget to reduce your probability. Yay! Okay, this one, a fair coin is tossed 2 times in succession. These are our equally likely outcomes. We want to find the probability of getting exactly 1 head. So there are 4 different outcomes for this. Okay, and when there's just 1 head, there's only 2 circumstances where there's just 1 head. So that'd be 2 out of 4, which if you divide by 2, that reduces to 1/2. We got to remember this one is really talking about an experiment where you toss a coin twice. And when that happens, you have to count all the outcomes. So HH is like if you got 2 heads. So this one is going to be 1/2. See, we got this. Okay, this is a single die is rolled twice. The 36 equally likely outcomes are shown to the right. So the different parentheses stand for like if you got a 1 the first time you rolled it and a 1 the second time you rolled it. We want to find the probability of getting 2 numbers who add up to, because sum means adding, 10. So let's see, 5 plus 5 is 10. We know that. And then we can kind of follow that rule here. 6 plus 4 and 4 plus 6. I think those are the only ways to get 10. Yeah. So there are 3 different ways to get 10 out of 36 possibilities. And when you divide by 3, that leaves you with 1/12. Oops. There we go. 1/12. Yay. Okay. This one here, if the spinner is spin once, find the probability that the pointer lands on a red region. So in this one, you're going to put, excuse me, that sounded weird, how many red regions there are, and there are 3 different red regions, and put that over how many spaces there are, and there are 6 different places you could go. And when you reduce that, that reduces to 1/2. So we're going to put that in there as 1/2. So it's always what you're looking for over the total number of possibilities. Okay, so this one, find the probability that the pointer lands on a region that is red and green. There are no regions that are both red and green, okay? It's just red or green. So since that's not a possibility, that would be 0. Okay. So in this one, this is empirical probability. This just means you can have a decimal for probability. That's all it means. So for this one here, find the probability that a randomly selected single parent in the US military is female. So I'm going to look here, okay? This is the female line here. I'm going to follow that. It looks like there's 26 females out of 103 total possibilities. Okay, so it looks like we're just looking at females, US military, it's all of those. So we're going to go 26 divided by 103. I don't know what's going on with my pen today. Do you guys see this? This is weird. Maybe I should close it. Close out my Epic pen and get it back again. What's going on? So anyway, we can divide 26 divided by 103, and we end up with 0.25, and it says round it to the nearest hundredth. So we're going to say 0.25. Okay, this one here. This one is saying find the probability that the citizen was an owner. So first, this stands for people in a certain country who moved in 2004 in millions. So if it's a 1.0, it means 1 million. So we want to know if a citizen was an owner. So first, we're going to have to add up all of these numbers to figure out the total number that we're talking about. So 11.6 plus 2.7 plus 0.3, 18.6. So I'm just adding all of them because if you'll notice, it didn't really give me a total category. So total, this is talking about 38.7 million people. And they want to know the probability that a citizen was an owner. Okay, so we're going to add up the 3 numbers in the owner category, 11.6 plus 2.7 plus 0.3. So it's 14.6 out of 38.7. We're going to divide, and you get 0.377, which would round to 0.38. So empirical probability is just a fancy way of saying decimal. So what is the occurrence called for which the outcome is uncertain? We would call that an experiment. Oh, I wonder if it's probability. Hold on, let's check. Oh, it is an experiment. So if we don't know the outcome, it's an experiment. That's what we would call it. Probability based on a set of equally likely outcomes is called, it's either theoretical or empirical. I think it's empirical. Nope, that's not right. Let's try theoretical. Yep,